Welcome to my video on the Fakugesi Project. The aim of this project was to engage in a festival that was hosted by Fakugesi. The festival was a concept display opportunity. This meant that designers were able to present concepts they created or inventions with technology and showcase them at this festival. The project followed the path of creating for a physical and digital aspect in which both aspects link through a product. My research began by investigating the various forms of digital technology related to the festival. My research showed the results of virtual reality, projection mapping, and augmented reality, and also how they work. Each digital element has their own positive attributes, but for the purpose of this project, I pursued the path of augmented reality. Augmented reality means that one has the ability through a device to change their surroundings, the objects in those surroundings, or even add objects to those surroundings. A famous example of this is the Pokemon Go app. Users are able to use their cameras, search their environments for Pokemon creatures and capture them. The creatures are not there, they are just artificially added. My design path and thinking meant that in order to create a product or physical object, I must understand more about what I want the object to be able to do and the possibilities I want to achieve. My initial idea was to follow a similar path of the Pokemon Go app, but instead of placing pre-rendered augmented objects on a screen, one would be able to create profiles and shapes and apply them to a live feed on the physical device. This allowed for thought to occur in my process that my device can use augmented software and be able to alter products. My final path of thinking involved the decision that my device will be able to make a 3D scan of a product and the users will be able to augment it live on their screen. It allowed also for features to be used such as sketching. Sketching would mean the user can create a 2D shape and be able to apply it to a selected product for augmentation. The application would then also be able to apply the shape to the product in a 3D format. An example of this would be that someone wants to buy a lamp, but they want to change the shape from square to something with more curves. They would sketch or select predefined shapes and sizes and apply it to the product to see the overall outcome on a live feed. The application would also then be able to list suppliers or companies that are able to make the product. This could provide many benefits for designers as well, as their concepts can become a reality if they are provided with this useful information. Precedent boards were created to help gain a further understanding on how existing augmentation software is used, and also what devices are used for this software. It was discovered that a lot of virtual reality devices are used in conjunction with the augmented software, but it is either pre-rendered or an old feed shown. The devices used commonly with live augmentation features on mobile phones or tablets. Using these devices may mean that certain technology is limited, or the battery may be preserved in order not to overwork the mobile devices. This raised an opening in my design thinking to rather create a device that can be used purely for augmentation and have advanced technology specifications and battery support. Sketching was carried out to conceptualize a device or shape at first to get the process moving. Many of these sketches resembled shapes and sizes of remotes, but upon further sketching it was noted the battery life of these devices may not be sufficient. Further sketching involved creating a larger shape or profile for the device and adding larger screens. A final conclusion was made with the Augment Scanner device in Sketch 3, where the device was made in appropriate sizes and scales and had buttons and a screen. Mock-up developments were carried out as a way of testing for other shapes and ergonomics of different designs. These provided useful information on scaling, shape outcome, ergonomics, and dimensions. Digital developments allowed for form play and manipulation to further improve on understandings of device sizes and shapes. It was finally decided to take Model 3 and Sketch 3 into a realistic and digital space. The device shown was created in 3D software and dimensions were applied from what was learned. The outcome as shown meant that the device would have various cameras, buttons, and a screen. Renders provided more realistic outcomes, much to what phone companies do to showcase a new device in various colors. A CAD drawing was created to show specifics on dimensions, accuracy, materials, and engineering projected views. Models were 3D printed to test further for more design understanding. A final prototype of the rendered concept was printed and would be used to showcase at the festival as the physical object. The device has multiple cameras that would allow for accurate 3D scans to take place and also allow for the best possible augmentation to be applied to the required product. The device has multiple function buttons and caption buttons as well. The estimated cost for creating a real-life working prototype is estimated around $1,500 to $2,000. After the first prototype has had changes and design flaws are resolved, an estimation retail value of the device is at estimation of $700 to $1,000. Thank you for watching. I hope you enjoyed.